have seen SN1 mechanism. Now see here, what is meant by the SN1 mechanism? We have seen already. So now we are seeing the SN2 mechanism. So that is a substituting nucleophilic bimolecular reaction in which two reactants are taking part in the reaction. So the one is a substrate, another is a nucleophile. Now see here, that is the rate of the reaction directly proportional to the concentration of substrate as well as the nucleophile. So both are important during this reaction. So that reaction is called the SN2 mechanism. So definition, what is? The rate of chemical reaction depend on the concentration of the substrate as well as the concentration of the nucleophile. Now see the example. That is a methyl bromide. Now it is a substrate. Nucleophile, that is the OH minus. Now this OH minus that displaces Br, so there is a formation of the methyl alcohol and Br minus leaves in the solution. Now see the kinetic rate of the reaction.
Now see the rate of the chemical reaction. So rate of reaction directly proportional concentration of substrate as well as concentration of nucleophile. Now substrate is the methyl bromide and nucleophile, that is the OH minus. Now see here. So previously we have seen that rate equal to K into concentration of CH3Br and OH minus. Now the reaction in which the rate of reaction depend on both. So here SN2 mechanism is a second order reaction. Previously we have seen that SN1 is a first order reaction. Yesterday, last period, we have seen also that it is a K is the rate constant of the reaction. Here in this reaction takes place only one step. SN2 that takes place in the two step, but now this reaction takes place in the one step. Reason is behind of that. Here three hydrogen atoms are there. So crowding along the carbon atom is less. So in this reaction, the breaking of C-Br bond and making of new bond, that is a COH bond, takes place simultaneously. So the reaction takes place only in the one step. Now see the mechanism. Here you will see that OH minus attacks from the back side only. So in this reaction, the breaking, now see here, breaking of C-Br bond and making of C-OH bond takes place simultaneously. Means what? At the same time, both are going simultaneously. So at the same time. Now see here. So this valence of carbon atom here 4. But in the transition state, that carbon becomes the pentavalent. This C-Br bond breaks. At the same time, new bond, that is COH bond, there is a formation of COH bond. So the negative charge is distributed at OH partial negative charge. Similarly, Br also carries a partial negative charge. So that is called the transition state. So this transition state is unstable. So after that Br leaves in the solution and this OH minus attacks from only back side. So there is a formation of 100% inversion configuration. So that is SN2 mechanism. Now if you will compare them between the SN1 and SN2, you will understand that some differences. So here the substrate must be primary alkyl halide. So nucleophile OH minus is required. So the solvent must be polar one. That is a second order reaction. SN2 is a second order reaction. The reaction takes place in only one step. There is a transition step in which carbon atom has a pentavalent and the partial negative charge on the OH and Br. So here only 100% inversion configuration takes place because of nucleophile OH minus attacks from the only backside. So some points are opposite. Breaking and making simultaneously. Nucleophile attacks only from the backside. Again the reaction completes in the one step, so it has one transition step. Nucleophile is required So the solvent must be polar, the substrate must be primary alkyl halide, and the SN2 mechanism is a second order reaction. So these are the differences between the SN1 and SN2 mechanisms. So you can write in proper way, that is SN1 also and SN2 also. Thank you very much for watching this video.